So hi everyone, you can see this is the experimental setup for to calibrate the given thermocouple and to determine the unknown temperature. So for this experiment we require micro voltmeter and hot air oven and the ice cubes or cold water I have taken here, cold water in a beaker, and two thermocouples of different range. So one having the range of 100 degrees Celsius and another 300 degrees Celsius. So here you can take the cold water or else you can take the ice cube in the beaker. And here you can see this is the wire made up of two different materials. So thermocouple is what the junction made up of two different materials. One is aluminum and another one is copper here. So this is the common junction. We have to dip that junction in the cold water or the ice cube containing the beaker and one end in the hot air oven. So instead of oven here we have the heater. So we put that junction in the heater or the hot air oven. So next here is the thermocouple micro voltmeter. We have to measure the potential difference across these two junction, hot junction and cold junction. So whatever the EMF we come across, we can note down here in terms of millivolt. So here is the diagram for this experiment. So thermocouple, two junctions. One junction is in hot air oven and another in the cold water or the beaker containing ice cube. So the potential difference or the EMF generated we can measure in micro voltmeter. So here is the aim of the experiment is to determine the unknown temperature with the help of thermocouple. And the apparatus, as I said, here we can see thermocouple, micro voltmeter, hot air oven, beaker with ice, thermometer of two different ranges. So first we should make the one end of the cold junction to the negative terminal and another end of the hot junction to the positive terminal of this device. So before that we have to keep the thermometer of different ranges. So it is a 100 degrees Celsius range. Thermometer must be put in the beaker containing cold water or ice, and the another thermometer must be inside the hot air oven. So next switch on the device here and also switch on the hot air oven. Okay, so you can note down the potential difference across these two junctions, cold junction and hot junction. So that is in terms of millivolt. Right now it is 0.36 millivolt. Once this heater gets heat up or the temperature increases, so EMF is also going to vary. So here the temperature of the cold junction must be constant. We must keep it at around 3 degrees Celsius. So for ice or the cold water the temperature is going to be minimum. It must be around near to 3 degrees Celsius. It is going to increase because the temperature is rising inside this oven. So it reaches around 300 degrees Celsius. Then for cooling you should note down the reading. And here the cold junction temperature must be constant. It must be around 3 degrees Celsius. You must maintain the temperature constant. And the potential difference across for the constant temperature of cold junction and the cooling temperature of the hot air oven you should note down. So with this experimental setup, the heating chamber must be provided. In case of that I have replaced with this so that you can understand how to perform this experiment. So this is the tabular column for this experiment. Cold junction temperature T1, hot junction temperature T2, EMF we should note down, and change in temperature we have to calculate. So cold junction must be kept at constant temperature around 3 degrees Celsius, and hot junction temperature, when it reaches the maximum value, so the corresponding EMF we will get 0. And for after that you should take the reading for hot junction for cooling. So the temperature is going to decrease, but the cold junction must be at constant temperature. So the potential difference across these two junctions you should note down with respect to the temperature. So 280 degree 2.1, it is going to increase gradually, and then after some temperature it goes on decreases EMF value. And one temperature you can take it as unknown temperature, you should calculate. Okay, so from graph you can calculate. In this tabular column you should write unknown temperature here, and change in temperature you can calculate by subtracting hot junction T2 temperature and cold junction temperature T1. So once you get the value of change in temperature, you should plot the graph of change in temperature versus EMF, so that from graph you are going to find out unknown temperature. So here is the equation for the variation of thermo EMF with respect to temperature. So E is equal to AT plus B into T, where A and B are the constants for the thermocouple and T is the temperature. So here is the nature of graph for this experiment. So here is the formula to calculate unknown temperature, that is temperature difference for that EMF. So here you have to plot the graph of change in temperature versus thermo EMF across the two junctions. So you will get the graph like this, and here the dotted line indicates the unknown temperature. So you can find out the unknown temperature from this dotted line. So how to calculate unknown temperature, here is the formula.